we want to talk in this section about the EV battery supply chain, and we're almost going from borehole to battery here. But if we were to start with Stewart, if we remember, Stewart's company has invested in the borehole in Eastgate in Weardale. And then we've got Seb. Now, Seb is from Watercycle Technologies, and Seb is taking the water and he's extracting lithium from it, hence the logic of this. And then Richard Taylor is from Green Lithium. You're taking the lithium products and refining it. And then we've got Colin from the Northeast Battery Alliance and Philippa from the Advanced Propulsion Centre. So you can see the use goes to batteries and then the end use all follows through. We like that. Your right to left. So let's talk about, you've given a great presentation of what you're doing in Weardale, Stewart. But you've heard now some of the issues that other partners have, the people who are financing it and the shortage of minerals and the way the Chinese are in the market. When you hear all of that put together, how do you feel about the prospects of the future of this investment you've made? Have you gone one stage too far?
No, I'm actually encouraged. And look, since the Romans, since even before that, the extraction of raw materials have been essential to civilization, but also it's been with risk and lots of different risks, whether that be capital, whether that be technology, whether that be people, etc. So risk management is actually a core competency for anybody in our industry. It's something that's well developed. Lucky to have a very experienced team of operators in the Weardale Lithium team. So it's something that we feel comfortable with because we can manage it.
Now, when we first met a year ago, you weren't absolutely sure that there was lithium in them there hills, were you? How did you go about confirming your prognosis?
Yes, there's lots of scientists in the room, so there was a healthy degree of skepticism, and you never trust anybody else's data. So we did our own, is the very simple answer. We went back into the boreholes, we did some advanced analysis, a wide range of exploration techniques, geophysics, chemistry, the hydroanalysis, and then took that a stage on with pumping and then working with DLE vendors, both in the UK and overseas. So a logical stepwise progression.
Now, as your PR guy, I've always advised him to travel with a little test tube, because in that test tube, you have the refined final product. Now, I haven't got it with you, have you?
No, because Seb won't let me have it.
He won't let you have it, okay. So you give the water to Seb, and Seb goes about extracting. So Watercycle Technologies, before we get into how you did it, just tell people about this new emerging company. It's a university spin-out, yes?
Yeah, we're a spin-out from the University of Manchester, and my PhD, it came out of my PhD research on water treatment and specifically looking at very concentrated brines. And the way that lithium is produced today is from two main sources: brines that you see in South America, where they use evaporation ponds, which essentially remove all of the impurities like sodium chloride and potassium, and then what you're left with is a kind of crude lithium product. Or you do hard rock mining, which is digging the ground. You have to heat the rock up to 1,000 degrees to change the crystal structure, and then leach it with concentrated sulfuric acid, which produces tailings, etc. Significantly worse environmental impact. So what DLE does is, rather than removing the impurities first and then what you're left with is lithium, we just target the lithium, selectively capture it using proprietary membranes, and then leave all of the impurities in the water. And that then allows us to return the water back underground, creating a closed loop.
Now, we have this little PR photograph on Stewart's presentation of you and Stewart in Weardale with you holding up this test tube of lithium. It looked like a test tube of rock salt or what have you. But tell us about the time it took to get that amount of lithium, and tell us about the quantity of water needed.
Yeah, so typically the process of adsorption or extraction of the lithium occurs within 15 minutes to 2 hours, say. And it follows this kind of sigmoidal curve, this S-shaped curve. So you get lots of stuff happening very quickly, and then you get diminishing returns later on. And somewhere there is that sweet spot where you basically minimize the unit economics, i.e. you can have it happening faster. And the kinetics is actually quite an important aspect of DLE technology, is getting it very quick, because when you're talking about flow rates that are cubic meters a second, potentially, you really need to have this thing happening quickly. When you compare that to evaporation pond processes, it goes from water to lithium carbonate in about 2 years.
Right. So the productivity gain is quite significant, your methodology. But in terms of doing it in volume, you've done it, that small test tube, you needed several litres, yes?
Yeah, so there's a big asymmetry between the amount of water that you need and the amount of salt that you produce. And obviously, the lower the lithium concentration, the bigger that asymmetry is, okay? In South America, you have maybe an order of magnitude, sometimes 2 orders of magnitude, higher lithium concentrations than you get in Europe. And so because of that reason, as well as high land costs and rubbish weather, evaporation-based processes don't work in Europe. They can't work in Europe. There's no way it would be economically viable. So what DLE does, as well as actually enhancing, improving, and addressing things like the water scarcity issue that you see in existing brine processes, is it suddenly enables these hitherto uneconomic sources of lithium to be viable. And so that means that we as Europeans can actually benefit from the lithium that we have underground, whilst addressing the water scarcity issue. Part of the reason that our process is actually a 3-stage process, where the selective lithium extraction is just stage 1. What happens subsequently then is the concentration of that lithium brine, which produces fresh water, which enables us to effectively have a water neutral technology. And then the final stage is to crystallize it, which produces the sort of final product, or we then send it to him and he would then refine it, for example.
So just before we go to him, going back to the small test tube in the photograph, the concentration of lithium in the northeast of England, in the North Pennines, what quantity of water was able to produce that concentration of crystal?
On the spot. I mean, I think you sent us about, well, I don't know exactly how much I can say. It's sort of...
Or is it commercially I'm asking commercially confidential stuff.
In maybe the... Yeah,
was it less than a cubic meter?
You just passed me an NDA signed here. It's sort of tens of litres.
Tens of litres.
And then you're talking about when you get to sort of production, you're talking cubic meters per second. So it's very large volumes of water, and that has to be managed properly. And there's ways to do that, and we're making sure that our approach to DLE encompasses aspects like what happens to the water when you remove the lithium,
yes.
What happens to any other wastewater. We are water people. This is where we started. And so the water strategy is key to unlocking DLE. And
how do you feel about that as the company that will do the extraction? Do you feel comfortable with the circular element of it, that you can extract and replace?
100%. That's exactly what the whole project is about. Again, we are water people as well. It just happens to have some minerals in it. It is really how we see life. So that's zero visual impact on the landscape. That's really important. And then also the water, DLE is only one part of probably a 15-stage flow sheet. That's how complex this is. And that flow sheet is changing all the time as technology changes, as our brines mature as well. So the water going back, being re-injected is core part, and wastewater treatment, again, is a key part of managing the sustainability and environmental aspects of our project. And actually, the EA mandate it, and we work very closely with them. It's just core business for us.
So let's move on to the next stage of the process, which is the refining. Now, green lithium based, or will be based, you're going to build your plant at PD Ports on the River Tees. It's a significant investment. So let's get into the company first before we get into the process. What are the key metrics of your business? What are you doing in the north?
Well, where better to start with the mission, which is to enable the transition to a sustainable energy future. Now, we've had some amazing speakers here today, so thank you very much to Weardale for putting this all together. It really is such a high calibre of people in the northeast here. But, to what Amanda said from Arch, You know, this energy transition, there's no silver bullet. It's horses for courses, and it's going to take everything. It's not hydrogen. It's not lithium on its own. It's not this lithium chemistry. It'll take all of it. And that's how I kind of want to try and explain what we're doing today. So Green Lithium is building the UK's first large-scale merchant lithium refinery on Teesside. We will be producing enough lithium hydroxide to produce 1 million electric vehicles. So that's around 50,000 tonnes. We will be ready in production by late 2026, 2027. Now, the beauty of this refining method is one, it's different to traditional refining methods that have been used in China. Rather than use a sulfuric acid leach process, yes, we do heat the process, but we're going to heat it using green hydrogen that's made right here in the northeast of England, using probably some of the wind energy that's been used from Equinor's wind turbines to power electrolyzers that'll produce the green hydrogen. That means when we do heat our furnaces to 1200 degrees, we will be doing so net zero, without any carbon expelled in that part of the process. We're then using an alkali leach process as opposed to the Chinese sulfuric acid process, which means our byproduct will be an aluminium silicate, which is an inert sand that can be used in the construction industry as a green cement. So further adding to the circularity of what we're all trying to do in that sustainable future that we're building. We are targeting at the moment to be taking a number of feed sources. The main one of this being hard rock lithium spodumene concentrate. This is because in the volumes needed today, that is the only place that you can get that amount of material of the grade needed to be able to produce enough lithium for these electric vehicles. However, our process means that we can take lithium carbonate from Weardale and others into our project, and we can then create the lithium hydroxide product which is needed for the electric vehicles from that. And we're doing that in a low carbon, as sustainable way as possible. Then we can also take a product from the black mass. So when we talk about recycling, you can then put that back into the refinery once you get the carbonate from recycled batteries. So we have that full circle situation. There is, you know, it's going to be a long time until we get there with recycling. There needs to be a lot more material put in to the value chain. But you know, doing things like not allowing the export of black mass from the UK or the European region, I would say, is a fairly good idea to whoever mentioned that before. Yeah, so that's what we're looking to do.
So you really are the poster boy business of the circular economy in the Northeast, I suppose.
I've been called a lot of things.
You can put that on your reference. Now, you're talking about a timescale to 2026, so 3 years, to build this plant. When the plant is up and running, what will be the possible outputs that it can deliver? What kind of volumes will you be able to provide of lithium to the sector?
Well, what we want to do really, working, you know, with the partners within Teesside, is we're gonna create a scale-up plant before that. The reason for this is that there's an amazing workforce here in the Northeast that are very adept and have a long history of working in the chemical sector, the steel sector, and you know, we've just been welcomed with local open arms, whether it be from the combined authority, the mayor's office, Ben, not obviously here today, but Chris taking his place, and we think it's the absolute perfect place to be able to do it. We want to work with partners like Weardale and like many of you in the room to be able to train staff on this scale-up plant. We'll do that over the next 2 years, and what that'll mean is when we commission our large-scale refinery, that everyone will be trained up, the commissioning times will be a lot shorter, we'll already have a saleable product going to market at that point through the scale-up plant, and it'll mean that everyone else can progress as well. So really, as I said before, the main outcome is going to be 50,000 tonnes of lithium hydroxide. That's 1 million electric vehicles worth. We do have a chance to expand to 75,000 tonnes with adding another line. But that's what it means.
It's pretty
A million
impressive.
electric
And
vehicles.
just in terms of numbers, jobs, obviously at the forefront of the general public and the politicians, and money. How much money do you think you're going to be committing, and what's the likely employment result?
So it's going to be around the 700 million pound mark, but by that time, it's probably going to be more of a billion, the way that prices are going up. But it's well justified. If you look at that compared with an oil and gas refinery, it's pennies. So
Okay.
it's on the jobs front, which is obviously the most important thing. It'll be over 1,000 in construction phase. And then we're looking at 250 long-term green careers that we expect to last for at least 30 to 50 years.
Thank you very much. Now, Colin Herron, you're from the Faraday Institute. You're a well-known academic. Many people in this room will know you, and even if you're not from the North East, Colin has a distinguished record, and he also is forged this North East Battery Alliance. So, Colin, when it comes to this mineral to manufacture process, are we overstating it? Can you pour some academic cold water on it, or are you equally enthusiastic that we can get there?
Absolutely no cold water. Can I just say one thing about this revolution of electrification? I was involved in 2009. I was in the time when the first shipment of electric vehicles, 11 plate, arrived, and I saw the first batteries made in the first leaf at Sunderland. Then nothing happened, literally. There was a lot of talk and lots of things behind the scene. Governments came up with some policies, and around 2020, things started to change. In the last 24 months, it's gone exponential, right? Massively. One of the challenges we've got in this region is that they're looking after lithium, but there's an awful lot over this side. And many people are digging holes in the ground and saying what they're going to do. But the region and the universities don't actually know what's coming. Could be 1,000 jobs. We might want so many engineers. We might want so many postdocs. We might want this. We might want it then. If Nissan go to 500,000 vehicles, which they might do, that would be another 3 battery plants in Sunderland. So we won't be training 1,000 people. We'll be training 3,000 people. This is the supply chain. If the battery plant opens in Camas, that's another 3,000 people, all at the same time. If Dogger Bank opens, which is going to open at the same time, they want the same people at the same time. So the supply chain is not just lithium, it's people, it's degree courses, it's degree apprenticeships, it's what the FE sector does. And then on the back of that, once the volume of all of this grows up, it sucks in more people. And Michelle keeps saying, I've got another one, I've got another one, I've got another one. So what do they want? When are they coming? How big are they? What's their demand? What's their requirement? So I work for the Faraday Institution, which is the research of 27 universities feeding in what's happening here. The North East Battery Alliance is the battery industry, and it's expanding to the miners, trust me, in the mining institution. So they're the academic, all 5 universities, and because of what we're doing, in my world, we don't split Teesside and the North East. So Teesside universities in all of this, we're all in together. The School of Engineering. So I'm advising our university and the other universities on what they've got to do, because we can't change degree courses and all of this and etc. in a year. So we have to guess in the supply chain what this lot are all going to do in 5 and 10 years' time, which they won't tell us because it's all commercially sensitive.
Well, that's the great challenge of your academic planning. But so you aren't quite clearly going to throw any cold water on the opportunities that exist, but you are explaining the stresses and strains of getting there.
Yeah.
I mean, when I started work in 1980, the steel plants on Teesside and Concert employed more than 25,000 people.
Yep.
Now they employ 400. So it is possible, but it takes a generation to scale up to that level of employment. And we could be at that level of employment, couldn't we, in this sector?
A little plug here. There is a wonderful museum in Newcastle called the Discovery Museum, effectively a science museum. Starting next year for 2 years, we're going to run Steam to Green.
the fourth industrial revolution. Why are we doing this? We want 400,000 members of the public and 100,000 under 12s to attend. Because everybody you talk about, an electric car battery, thinks it's a 12 volt. They don't know what it is. And I've just got this law because I want some bottles of water. I want some lithium. I want the cells. I want the batteries. I want the cutaway car. I want the charging posts. I want the wind turbines. If we do not educate the public as to what this is, because trust me, if they listen to the BBC and they read The Sun, they've got a completely distorted view of what this technology is. So this is really big. Concept was steelworks. Northumberland was mining. Getting miners to understand what a clean room is when their parents came home filthy and had a bath in front of the fire to working in a clean room. This is very different.
I think you point well made. And by the way, you do need to show this test tube of end product. It's very useful. Now, the Advanced Propulsion Centre, we've heard a little bit of your research, but you are funding some really innovative measures. It is actually worth going on your website because there's some great video about all sorts of different case studies. What involvement have you got in the way that this chain is going from borehole to battery?
Well, I think, so we're 10 years old, started in 2013. And if you go back to our case studies back in 2013, it was very much around the relationship we had with the OEMs and their transition towards low carbon and obviously now net zero. So, a lot about engine downsizing, improving performance. And over time, that's massively shifted. And then in 2020, due to the relationship that we have with industry and the relationship we have with government, industry was saying, okay, we've got the technology, but where's the supply chain? And the shift in the way that the projects have developed, the collaborative research and development projects have been created and the partnerships that we have with industry, you've seen that go more upstream around the supply chain and looking at how we develop it. 2020, we had the Automotive Transformation Fund. So that was a big change in the support for capital investment. Now, this capital investment isn't just to, provide companies with building things. It's to help them de-risk the offerings that they do to their investors or internally within their own business cases. And successes we've had within that so far are things like the expansion of the AESC and Vision plant, the transition of the Ford Halewood plant, so that went from producing transmissions through to now producing EDUs. And what actually, though, the reason that happened is because previously Ford had around 9 different collaborative research and development programs with us. And that was the transition of the workforce they have now. So those guys who were working on the engines, those guys were looking at how they could put digital tools and capability within their systems. So actually, when they went up against the factory in Cologne, the UK factory went out, Halewood went out, because they could demonstrate that transition and that efficiency. And again, that safeguarded all those jobs at that facility. There's also the expansion to Johnson Matthey and obviously a number of other projects and companies going through that pipeline for investment. But it's not only the capital support, it's about making sure that the feasibility of, when we have these new disruptive companies, a number of them on the panel here and in the room, how do they make sure that they can demonstrate a business case to their investors? So it's then about working with these organisations to say, okay, we can support you this, we can help, give you some funding so you can create that business case going forward. But not only that, it's so that the UK can demonstrate capability and we can feed that back into the government to say, look at what we've got. Because I think there's often, and I don't know, I want to say a naivety maybe that we have a lot of technology development within this country. People don't often know what's in their backyard, let alone, what's on either side of the country. I know we talked about the West Midlands earlier versus the North East, but actually, I'm not going to get into a geographical background. But one of the things that has, struck me massively through the work that we've seen, and you can see it along this panel and other things that have been said today, is the amount of collaboration that is happening within the UK at the moment, where we recognise that actually, we are completely, pretty much all beholden to China. So what are we going to do to make sure we've got resilience in this country. You know, recognizing actually we might not be able to, you know, fulfill every demand that we have, but what can we do to get a step closer, and where can we collaborate to make sure that we are sharing that best practice? We're feeding back into the education institutions. We're retraining the workforce that we have now. We're transitioning those skills across the different sectors to aggregate demand to make sure we get the investment.
I mean, I've seen it myself in my own business practice. There's three massive businesses in the Northeast that were pioneering on batteries and motors. They were bought by Turntide Technologies, an American company, put £100 million into the UK because our firms had the know-how.
That's it. And I think, you know, so we work across those technologies, and you know, investment in the UK and maybe, you know, that Turntide example, it's how do we make sure they retain that research and development capability and that manufacturing output here. So working with them to make sure that retain is really important.
Okay, it's a good opportunity for a couple of questions from the floor, if there are any, before we move on to our next speaker. We've got a range here, borehole to battery. Any other questions we've got? Yes? Down at the front.
Oh. This question's for the whole panel. There is some support for each of you in the battery supply chain, and we've got the Faraday Institute, we've got the APC, and we've got various grant bodies that have provided invaluable funds to Weardale over the last couple of years. Do you think we can get there without bigger government intervention?
Maybe goes to the subsidy point we heard earlier from Henry. Anyone want to pick that up?
So as Amanda Van Dyke from Arch also said, it's going to be difficult without the government standing in to at least make the UK a attractive place for people to put money. And the reason that how they can do that is how they are currently going about it. What the Automotive Transformation Fund is doing, the way that those grants are set up, is in a way that crowds in private investment. And you achieve certain milestones and money is released and it is all paid. You spend the money and then you claim it back. It's a very sensible way of spending taxpayers' money. It is not coming out and saying we're going to, you know, just flood all these businesses with money. And that's the UK way, that's the UK Treasury way, and it's the way that has been always done. It is very different to the Inflation Reduction Act and what's happening in the US. What that means, obviously, it doesn't have a higher impact. The Inflation Reduction Act is often described as a high-impact American sport. You know, baseball, American football, bang, it's happening. Whereas the UK is a lot more gradual and subtle than that. There are opportunities through the UK Infrastructure Bank that are now developing and deploying money. We've seen that with Cornish Lithium down in the southwest, and they will be looking to do that with others, I'm sure. I would say the UK government have been, over the past couple of years, been getting educated on what the opportunity is, what the demand is likely to be, and where we can play a part in this supply chain, and obviously how we can make sure that we have our natural resources secure. So there's been a lot of evidence gathering, and now I think we are finally starting to see some actions being made, and you know, whether it's through the UK Infrastructure Bank, whether it's through APC, whether it's through the UK Business Bank, there are things happening. The opportunity to help is where you're taking a lot of the businesses that are starting in this green energy transition are, Stewart said, they're risk, they're companies that have been prepared to take the first step in an emerging market, whereas much more mature businesses will stand aside. There is often then created this thing called the Valley of Death, where you have a company that's got a great idea, they can get their seed funding, but then to take it to actually commercialization and construction, there's a bit of a funding gap there. And that's hopefully where these government incentives packages can come in and fill that valley of death. I think personally the UK government is doing a good job at the moment with this. It's just not as high impact as being compared with America. If we look back 2 years to see where America was, they were behind us. They were behind everyone as far as energy transition. So I'd say the race has just been run at the moment, and there'll be plenty of time really for us to catch up. But we do need to be putting those incentives down.
I'm going to give you the last word, Colin.
Right. One of the things I would ask is, if we know what the goal is, and we know what we're going to try and achieve, help us support, deliver what we want to deliver, right? Ask us what we want. Don't put endless trials of technologies that's not going to work. Invest that money in the region. And this is a regional whinge, because I've just seen that there is a government strategy, battery strategy task force. There's 17 people on the task force and 1 from the Northeast. And that person is just relocated from the West Midlands. We need a voice in London to tell them what these people need to deliver what they need, which is different from financial intervention. And it is so difficult.
Well, that's a very good point. And I'm going to leave it at that because it's a good point to end. Can I ask you to thank our panel, ladies and gentlemen?